Hello everyone, this is the last part of presenting problems on moment of a force about a point, applying the principle of transmissibility of a force and Varignon's theorem, problems on couples and equivalent couples, and resultant of the general coplanar forces. So the principles and discussions are again in Statics for Beginners 3. You have there a more than 1 hour lecture with additional examples. There's so many examples also there. You might be interested with the examples, but there are 20 problems here. This is the last part. The last part consists of 20 problems and it is they are level 15 to 20. So level 15 problem, the force F acts along line MA where M is the midpoint of the radius along the x-axis. Determine the equivalent force couple system at O if theta is 40 degrees. So here is the given figure, theta is 40 degrees. This is r over 2 because m is the midpoint, OA is the radius, so we can find the length of AM. After we find the length of AM, we can compute this vertical distance from point A to x-axis because theta is given and that's the radius. So this is r sine of theta, r sine 40. Then we can solve for the angle that MA makes with the horizontal as well as the force F makes with the horizontal. Then after that, we apply principle of transmissibility of force. We move F at M. We have horizontal which passes through O and vertical which has the only moment about O which is counterclockwise. So that's the flow of solution. So first, let's solve for distance AM by cosine law. Distance AM square equals OA r square plus OM r over 2 square minus 2r r over 2 cosine of theta which is 40 degrees. So distance AM is equal to 0.695r, 57r. Then we compute this vertical distance. That is OAR sine of theta, sine of 40. So r sine 40 degrees. Then we compute for alpha. Sine of alpha is r sine 40 over AM. That's also alpha. This is the vertical component of F sine alpha. We can move it on its line of action by principle of transmissibility of force. The horizontal component will not be named because it has no moment about O. So sine alpha is r sine 40 degrees over AM, which is 0.69557r. Cancel r, so we can compute alpha. 67.51 degrees. Then its moment about O is F sine alpha times r over 2. Counterclockwise. So F sine of 67.51 degrees times r over 2. Expressing in decimal, MO is 0.4620 FR counterclockwise. We now finalize the answer. The force couple system at O is F at alpha theta x with respect to the positive x-axis equal to alpha equals 67.51 degrees and the moment is 0.4620 FR counterclockwise. So that's the force couple system when this system is replaced by a force with the force acting at O. Level 16, the problems here are not, the solution is not so long, but you need the trick in mechanics and the principles so that we can solve this in a short manner. Knowing that the forces P and Q are equivalent to a single force R that passes through point A, determine P. So take note the resultant of these two forces can be replaced by a single force R that passes through point A. Since the resultant passes through point A, the moment of the resultant at A is 0. And Q and P are the components, so the moments of these components about A is also 0. So that's the concept. The horizontal component of P passes through A, so it has no moment about A. The vertical component of P is P cosine 35. It produces counterclockwise moment about A, while the moment of Q about A is clockwise. So if we treat counterclockwise positive, clockwise negative, then the moment about A is 0. So that is moment about A of the resultant is 0, and that is equal to, these are the components, 0 equals P cosine 35 times 8 times minus 30 times 8.5. Therefore, we can solve for P. 30 times 8.5 divided by quantity 8 cosine 35. So P is 38.91 pounds. Level 17 problem. The flanged steel cantilever beam with riveted bracket is subjected to the couple and two forces shown, and their effect on the design of the attachment at A must be determined. Replace the two forces and couple by an equivalent couple M and resultant force R at A. So we replace the system with an equivalent force couple system, and the couple is denoted by M, transferred at A. So simply we compute for Rx. Rx, beginning with the 2 kN load, it is pointing up to the right. The X component of 2 kN is 2 cosine 70. So Rx is 2 cosine 70. Then the other force, the component is this component here, going to the right also. So plus 1.2, since the slope is 3 vertical, 4 horizontal. So times 4, and the hypotenuse is 5, 3, 4, 5. So this must be 5. So plus 1.2 times 4 over 5. So that is Rx. Rx is 1.644 kilonewtons rightward. While Ry, the vertical component of the 2 kilonewton load, is upward, and that is 2 opposite of 70, so 2 sine 70 Ry. Then the y component of 1.2 is downward, it is pointing down to the right, so minus 1.2 times 3 over 5. Hypotenuse is 5 here. So Ry is 1.159 kilonewtons. So we can now set up R. R in vector form, R is 1.644I plus 1.159J. So that is pointing up to the right. Now the couple at A, let's assume clockwise positive. So let's begin with 500 Newton meter clockwise. So take note, the units here is Newton meter. So we must express 2 kilonewtons into 2000 newtons, 1.2 kilonewtons into 1200 newtons. So MA is equal to 500 clockwise. Then for this 1.2 kilonewton load, the component which produces clockwise moment is the vertical component, while the horizontal component is counterclockwise. So let's begin first with the vertical component, and it is 1200 times 3 over 5, and the moment arm is 1.5, vertical component clockwise. So plus 1200 times 3 over 5 times moment arm 1.5. The horizontal component is counterclockwise about A. This is point A, the bottom of the cantilever beam. So it is minus 1200 times 4 over 5, that's the horizontal component, then times 0.15. So minus 1200 times 4 over 5 times 0.15. Then for the 2 kilonewton load, let's begin with the clockwise component, which is the horizontal. It is clockwise about A. The moment arm is 0.15, this is 0.15 here, because this is the horizontal line through A. So this component is 2000 cosine 70 horizontal, so that it is clockwise about A times 0.15. The vertical component is 2000 sine 70, and its moment arm is 0.5 plus 1.5, so 2 meters. So minus 2000 sine of 70 degrees times 2. So using your calculator there, compute all this. MA is negative 2220 Newton meter. Since our assumption clockwise positive, then we will change that to positive 2220 Newton meter counterclockwise. So we now finalize our answer. R is quantity 1.644 I plus 1.159 J kilonewtons. And MA moment is 2200 Newton meter counterclockwise. That's it. Level 18 problem. Determine the resultant R of the three forces acting on the simple truss. Specify the points on the X and Y axis through which R must pass. So here is the figure. There are three forces again. Let's compute for Rx. Beginning with 20. 20 sine of 30 rightward, so it is positive, then minus 25. Rx is 20 sine of 30 degrees minus 25. So Rx is negative 15 kilonewtons. Ry, there are two forces with y components. Both are downward, so beginning with 20 here, negative 20 cosine of 30, Ry, then minus 30. So Ry is equal to negative 47.32 kilonewtons. So the resultant therefore in vector form is quantity negative 15I minus 47.32 J kilonewtons. And let's compute moment about O so that we can find the X and Y intercepts. Let's transfer the force and components later. So MO is clockwise positive beginning with the horizontal. This is horizontal 20 sine of 30 degrees so that it is clockwise about O. That's the assumption only. So 20 sine 30 times moment arm 5. The vertical component is also clockwise. You may combine it with 30. Let's just compute one by one. Next, 20 cosine 30. The moment arm is 6 plus 3, so 9. That's also clockwise. The next 30 clockwise about O times 9. And finally, 25 is counterclockwise about O. So minus 25 times 5. So using your calculator, MO is equal to 350.9 kilonewton meter clockwise. Since the resultant is down to the left, let us say it crosses the x-axis at this point. This is the horizontal component. I will not put 15 there to the left because its moment about O is 0. It passes through O. Just this 47.32, which is clockwise. And let's call that the A, x-intercept. So its moment is 47.32 times A, clockwise, equals 350.9. Because the moment of the resultant is also the sum of the moments of its components. Since the moment of the components about O is 47.32 times A, then that should be equated to 350.9. So the x-intercept is 7.415 meters. Likewise, moving along the line of action here, so this is 47.32, that's 15. This time the 47.32 passes through O, so it produces 0 moment, just the 15. Call this the y-intercept, which is below the x-axis. So although it is positive here, but it is below the x-axis, so it should be negative. The moment about O is 15 times B clockwise, then that is equated to 350.9 equals 15B. So B therefore is 23.39 meters below x-axis. So final answer, R is negative 15I minus 47.32 J kilonewtons. Then x-intercept 7.415 meters. Y-intercept negative 23.39 meters. So that's it. The asymmetric roof truss is of the type used when a near normal angle of incidence of sunlight onto the south-facing surface ABC is desirable for solar energy purposes. The 5 vertical loads represent the effect of the weights of the truss and supported roofing materials. The 400 Newton load represents this one. These are the 5 vertical loads. The 400 Newton load represents the effect of wind pressure. Determine the equivalent force coupled system at A. This is point A. Also compute the x-intercept of the line of action of the system resultant treated as a single force. So observe that these 5 forces are symmetrically applied. Meaning to say, this is the center, 5 and 5, then 500 to the left, 500 to the right at the same distance from the center. 250 newtons, 5 meters from the left, then there's another 5 meters from the right, rather 250 from the left to 50. So therefore, we can cancel all these 5 loads and replace it by 2,000, 500 plus 500 plus 500 plus 250 plus 250, 2,000 downward at G or any point along the line of action, but it should be at G for easy purpose so that this 400 Newton force can also be moved along its line of action at G. So we can easily combine. So therefore, Rx is just 400 cosine of 30. So Rx is 346.4. While Ry is, we have 500 already, downward, negative 500, then we just add 400 sine of 30. So let's cancel all the vertical loads. So Ry is negative 2000, then negative 400 sine of 30, downward, because this is downward. So Ry is negative 2200 newtons. We then cancel 4000, 400 other, then put these components of the resultant at G, so that it is obvious that the resultant passes through G, that we don't need to solve for the x-intercept, which is obviously 5 by principle of transmissibility also. And the moment about A is also obvious, 2200 times 5 clockwise. So moment at A is 2200 times 5 clockwise. So final answer, R in vector form, quantity or 11,000 Newton meter clockwise, moment about A. So final answer, R is 346.4 I minus 2,200 J newtons. Moment at A is 11,000 Newton meter clockwise. X-intercept is, there's no need to compute it, it's obvious 5. So you might say this is very easy. Easy after I present the solution. Short because of the trick. But for most of you who will analyze this, definitely your solution will be complicated. And I just hope that if it is complicated, you still arrive at the same answers. What if you do not arrive at the same answer? What is important, you arrive at the same answer. So it's a technique also. Lastly, level 20. This is a very easy problem if you know the trick. The 3 forces of magnitude P can be replaced by a single equivalent force R acting at point A. Determine the distance x and the magnitude and direction of R. So again, R is the resultant that will replace the system acting at A. If the resultant acts at A, then the moment about A would be 0 of these components of these forces. So that's the trick. So Rx, these two will cancel because that's just a couple. There's no Rx. Ry is equal to P upward. And Ry is also equal to the resultant upward. So R is Ry equals P upward. So we have R equals P upward. Let's transfer it at A. So that's why moment about A is 0. And if we treat counterclockwise positive, so the moment of this P here is P times this distance is L minus X. That's counterclockwise, then equals clockwise moment of this couple, clockwise. Independent of the moment center, or you sum up moment about A. This is 0, then minus P times L over 2. Cancel P, L minus X equals L over 2. So X is L over 2. So that's it.